589 N-ary Tree Preorder Traversal. So what is preorder traversal? In a preorder traversal, we first traverse the root node, and then we traverse the left children of the root node, and then the right subtree. Basically, we traverse the root node and then the left subtree, and then move towards the right subtree. Here in this example, we traverse this root node first and then their children. So we traverse from the left hand side, so we traverse this left subtree first, and then this middle subtree, and then the last one here. And again, when we are traversing this subtree, we do the same thing. We traverse the root node first, and then the left subtree, and then the right subtree. So here you see, right, we are actually doing some recursion because we are repeatedly doing the same thing again and again. So, and also, as you see here, what are we doing is we traverse this node, we go to the left, and for this case we need to traverse this whole tree before we move here. And in order to traverse this whole tree, we again go to the left of this. So we keep going to the left until we have reached the end, and then only we go to the right. So what we are actually doing a depth first traversal. So that is what we will be doing here in our case as well. So let's start working on our algorithm. So let result equals to, so this will be our resulting array, and let us create a DFS function. And then let's call our DFS function from here and return the result. Now we are passing the root value here. What if the root value is null, which means like we are given that the number of nodes in the tree is in the range 0 to 10 power 4, which means the root could be equals to null. So if the root is equals to null, then we'll just return nothing. And then since we are doing a DFS here, we know we are given the value and the children. So first of all, we also need to create a queue. No, we don't need to create, we just need to push. If the root exists, then we are just pushing the root because we are traversing that root. Push root that value, and then we traverse its children. So we see if the root is not, if not, then we push it to our resulting array, and then for each of its children we traverse each of its children. So for let child of our children, we do DFS on each of these child, and yeah, we keep on doing the same thing. So let's try running our code. Great. Let's use some example test cases. Great. And let's submit this. Great, it's accepted. There is one way we could optimize this problem. So what we are doing here is we are just calling DFS function over our root, right? So we are doing the same thing here, and this function is almost doing the same, is like also calling upon its root. So we can just remove this function call, and instead of DFS we could just call our preorder. But now the result, we need to pass our resulting array here. this. So what are we doing is we do the same thing. We are passing the resulting array. So initially, and we also pass a result here. So initially we do not have any result array, so it's just empty, and then the root value. So we check our root equals null. No, it's not. Then we push it to our resulting array, and then for each child of the root, we do the pre-order traversal, and now we pass our resulting array because we want all the values to be pushed into the array. And then at the end we just return our results. Let's try to run this code. Great. Okay, so we need to check for the condition where where the root value is null, so we need to return an empty array.